Welcome, this is modeling linear systems. You know, linear means that we're going with an exponent of 1, so it's x to the first or y to the first. Systems means 2 or more equations. So modeling generally means it's going to be real world. Ouch. Okay, so here's the scenario. I've got 10 pencils and pens that I bought for $4. The pens cost 50 cents, pencils cost 25 cents. How many of each did I buy? Well, you could do a lot of guess and check, but it's really not hard to figure it out. I just say make a table here and think about your quantity. Just make an equation that has to do with quantity. How many of these did you buy? You say 10. Okay. Pencils, let's call that C, and pens, let's call N. So N plus C would equal 10. Now we do a value equation. I spent $4. So when I went up to the cash register, every pencil that she ran across the little scanner, it charged me 25 cents for each one. Correct? And for each pen, it charged me 50 cents. But they added those two together to get the $4. You've got your two equations right there. Quantity equation, the pencils and the pens add up to be 10. And the value equation, pens I was charged 50 cents each, pencils 25 cents each, and my total amount I was charged $4. Use those as your two equations. So you could end up, now I switched the order around on this, sorry about that. You could end up taking the pencils and multiplying by negative 0.25 to get an answer here, but I realized that if I take 4 quarters, it makes 1. So I'm just going to multiply by 4 on this one. 4 quarters makes $1. 4 times 50 cents, well 15 50s a dollar. 50 more would be $1.50, and 50 more would be $2. And 4 times 4 is 16. Now I can bring my other equation down here. I'm just going to solve this system by adding them. So I have C, N, and 10. Now I could put a negative on all of these, but I can see easily if I put a negative on these, then I end up with a positive answer here. So when I add these, 1C and a negative C, that's a negative 1C. Those are a zero pair. 2N minus an N would be an N, 1N. 16 minus 10 would be 6. So I know that I bought 6 pens. If I bought 10 altogether, then I know I bought 4 pencils. Okay? Now let's do it by graph. Over here on the graph, C plus N equals 10. So when I graph that, if I let the pens, number of pens, be my X, and number of pencils be my Y, then when X is 0, Y has to be 10, and when Y is 0, X has to be 10. So I know that I'm out here at 10, 10. Okay, where did my pen go? Or I mean my ruler. Don't see it. Okay, I'm going to have to just do my best here. Now, why is it that I don't extend that line into the negatives? Remember, this is number of pens, number of pencils. Why wouldn't I extend to the negatives? Now, the next thing is my value. Okay? I can write an equation here, 0.25. C plus 0.50 N equals thing I would do is I would probably go ahead and say, what if I have, now the pins is X, pencils is Y. So if I have 0 pins, how many pencils would it take? How many quarters in $4? If you say 16, absolutely right. Now, I get 0 pencils, and I'd say how many pins now? Well, 50 cents, there's 2 and $1, so there's 8 and $4. So I go 16, 0. Oh, and I've got that flipped around, I am so sorry. This is your Y this time, that's your X. So 0, 16, when I put it with the X first. I did the same thing on that last one. I'm so sorry. I should be having the X and the Y first. X before the Y. The last one, it didn't matter because they were both 10, 0. Eight, 0. Okay, so I go out to 8, 0. I go 0, 16. And do my best to connect those. Those cross at approximately 6, 4. Right there, 6, 4. So we did pretty good even without a ruler. Okay? So there's 2 ways to solve the modeling equation. When you come into class, you're going to have a different modeling equation, but very similar problems.